Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Interplanetary Climate Change, Cosmic Rays and Solar Activity. Now, as detailed in the previous article in the series dealing with Planet X and the current grand solar maximum, the stellar cores belonging to the Planet X system seem to have caused the Sun to greatly increase its activity as indicated by sunspot number in the last 170 years, and also to become extremely weak in terms of light emission and magnetic field associated with sunspots. Now, the Sun's interplanetary magnetic field, which is the solar magnetic field arriving at the Earth's magnetosphere, which is thus associated with the charged particles in the solar wind, has greatly increased in strength as well. According to Dr. Mike Lockwood, the Sun's IMF has increased by a factor of 2.3 since 1901, thus indicating that the Sun has become a lot more active. And in fact, this agrees with this plot of the interplanetary magnetic field, or here called the heliomagnetic field, which shows an increasing trend as well. And this comes from ice core data, and this data comes from 1428 up to 2005. You can see that the increasing trend was even sharper here between about 1900 and just after 2000. And both of these would indicate that the Sun, an increase in the IMF would indicate that the Sun is putting more energetic particles in the solar wind, and perhaps that particle density in the solar wind is increasing, and can only indicate that the Sun is more active. And ice core samples come from ice sheets in Antarctica and Greenland, and the age can be determined, and the data comes from radioactive isotopes, carbon-14 and beryllium-10. And their abundance can be used to determine solar activity. And here we see a photograph of an ice core sample, which comes from a depth of about 1.2 miles. You can see someone here holding one that has just come out of this tube, which is used to collect it. Now, so these layers show the accumulation of ice through the winter, and these are sandwiched between these lines indicated by the arrows, which would indicate the summer layers. Now, many factors would come into play for a model that would translate this data into solar activity. But one of the ways that these models are come about is through comparison with data, and some of the data that is available is sunspot numbers. This data is available since 1610, and we see some of this what comes from this data here. This is relative sunspot number, and this is sunspot group number. Sometimes the people observing the sunspots only counted group numbers. They didn't count any individual sunspots. So there's more of this data available. And this gray line here shows the averaged, the 11-year averaged sunspot number, and as we can see, it shows an increasing trend, and this would indicate that the Sun has become more active in this time. But it's commonly believed that, first of all, the most energetic cosmic rays reaching the Earth are galactic cosmic rays, which does come from outside the solar system, and that the Sun, when it is less active, allows more of these cosmic rays to enter the solar system, thus to reach Earth, and that, in fact, this leads to increased cloud formation. So if the Sun is more active, then we should have less cosmic rays reaching the Earth. But we actually have more cosmic rays reaching the Earth, and yet we also have increased solar activity. So the data shows the opposite of what is commonly believed. And as you can see here, we have a cosmic ray, and this comes from the Moscow neutron monitor. So it actually shows increasing trend of neutrons, and neutrons are of course associated with cosmic rays because it is fast-moving cosmic neutron rays are produced when cosmic ray particles interact with particles in the Earth's atmosphere. So fast-moving neutron detection can be used to determine the cosmic ray flux impacting Earth. So this shows an increasing trend in cosmic rays. And this increasing trend is also shown in the data here, also coming from neutron monitors and ionization chambers, which shows an increase in cosmic rays since at least 1936 and goes along with the increase in sunspot numbers, which we see plotted in this plot as well. So the increasing trend seen in the data from the Moscow neutron monitor indicates an increase in cosmic ray flux between 1991 and 2018. So this starts from about 1991 here, goes all the way to 2018. And this shows an increase between 1936 and 2000. So this would indicate that the increasing trend between 1936 and 2000 continued beyond 2000. So either way, we have a continued increase in trend in cosmic ray flux, and we have an increasing trend in solar activity. And this seems to have started in about 1900. The IMF also seems to have started in about 1900. This is close to the date when noctilucent clouds were first seen in the Earth's atmosphere. And these were first seen in about 1850, and this indicated to me that the stellar core matter started reaching the Earth's atmosphere about then, and this is most likely therefore the date when the stellar core system started the invasion of the solar system. And here we see one of the stellar cores that has been observed in the outer corona of the Sun. This is a very large object. I have written an article where I show that it has to be very close to the Sun, and that therefore we can estimate its size. And it seems to be about 3 times the size of the Sun. Well, actually that would be a minimum size. It may be actually larger than that. But we can do a direct comparison of the size of this object with this white circle, which indicates the size of the Sun. And therefore this is one of these very large objects that is observed in the Sun's corona. Now, it's not possible for solar activity to increase and cosmic rays to also increase if increased solar activity shields the solar system from cosmic rays. This would mean that the Sun should have become increasingly protective, and thus the number of cosmic rays reaching the Earth should have dramatically decreased. But the opposite has occurred. The Sun became more active, and the cosmic rays have increased at about the same rate as we could see in the data shown above. This can only mean that the cosmic rays are coming either directly from the Sun, which has therefore produced more cosmic rays due to increased activity, or it is coming from a combination of the Sun and the stellar cores, which have also caused the Sun to greatly increase its activity, as I have shown in Article 3 of the series. Either way, since it is the presence of the stellar core system in the solar system which has led to the Sun's increased activity, and and yet declining strength, we can therefore reasonably conclude that it is the presence of the stellar cores in the Sun's corona and in the solar system which has led to this increasing trend in cosmic radiation. And that these are not galactic cosmic rays, but cosmic rays produced inside the solar system, and most likely coming from the very center of the solar system, as this is the likely region where most of the invading objects are found. In addition, since these objects are not likely to leave, and since the number of objects is likely to keep increasing, cosmic rays reaching Earth are likely to continue to increase. Thus, the fact that the idea that the sun is less active, usually talked about in terms of a grand solar minimum, and that this has led to an increase in cosmic rays and in cloud formation, seems to indicate that a disinformation campaign is underway. Increased cloud formation seems to in fact have increased because of artificial cloud seeding or chemtrails, which is being done in order to hide the invading system from the Earth's population. And you may look at Article 218 entitled Chemtrails, Sun Simulators and Stellar Cores, a multi-level conspiracy, for more details on that. Thus, the disinformation campaign seems designed to hide both the stellar cores and their effects on the Sun and the Earth. In conclusion, the Sun's IMF, or interplanetary magnetic field, and sunspot number data both show that there has been a sharp increase in solar activity for many years now. The sunspot numbers clearly show that the sharp increase started in about 1850, when the Planet X system of stellar cores seems to have started its invasion of the solar system. Cosmic ray flux has increased in tandem with the sharp increase in activity, thus suggesting that the stellar core invasion is responsible for this increase, which is also likely to continue. Furthermore, the promotion of the idea that the sun is going into a grand solar minimum appears to be the result of a disinformation campaign designed to hide the truth from the Earth's population. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.